Hello, my name is Ronald J. Daskovich, and welcome to our lesson on definitions of AI. So what is a good definition of artificial intelligence? You can kind of think of it as the simulation of human intelligence in computers. Human intelligence is made up of learning, reasoning and problem solving based on that learning, and then self-correction when we get something wrong. And the way that artificial intelligence is used today is to improve services and products. Think about Siri and Cortana and Alexa and how those help us in our everyday lives. A subset of AI is actually machine learning. So what's a good definition of machine learning? It starts with a set of data. You present that data to an ML algorithm. The ML algorithm figures out the important relationships and infers a result based on what it learns. And this fundamentally differs from an expert system where the programmer provides the rules. In the classic case of an expert system, if we want to identify a cat in a picture, we'll be very verbose in a set of rules that we give to the computer to figure out what makes up a cat. A cat has certain colors, and a cat has whiskers, and a cat has ears, and a cat has sharp teeth. A cat has big eyes. With a machine learning algorithm, on the other hand, all we're going to do is provide lots of examples of pictures of cats that are labeled cat, and we're going to let it figure out the rules itself. Machine learning itself can be broken down into supervised learning and unsupervised learning. In the example of cats that I was showing you just before, our pictures of cats that we present to our model are actually labeled. It's labeled cat. We train the model, and the trained model is used to infer a new label on the new data. It's important to note that machine learning models are always inference models. We're never 100% sure. A good example of supervised learning is email spam detection. Is this email a spam or not? And then we can have an application based on whether it's spam or not give us that message if it is. A good example of unsupervised machine learning, on the other hand, is when the input data has no labels. What we're trying to do here is get the algorithm to look for patterns in the data, and then quite often the patterns that we find will be used for classification problems in the future. A good example of unsupervised learning is market basket analysis. Types of supervised machine learning that we have include regression, where your result is going to be continuous. And a good example of that is how late will the flight be. Classification, on the other hand, is a discrete class. Will your flight be late, yes or no? Or in a multivariate example, will your flight be early, will your flight be on time, or will your flight be late? Another good example of supervised machine learning is content-based recommendation, where we explicitly state movie characteristics and we explicitly know the user preferences. For example, I have rated science fiction movies that I've seen previously highly, so therefore, if a movie has a stated characteristic of being a science fiction movie, I'm probably going to like that movie. Another example would be a favorite actor or actress or a favorite director, for example. Types of unsupervised machine learning include clustering. Remember, our data is not labeled in unsupervised examples, and what we want to do is discover inherent groupings of our data. An example of that would be grouping customers by their purchasing behavior. Another good example is unsupervised machine learning, where we explore things that are often bought together. An example of that would be the beer and diapers urban legend, where a father goes in to buy diapers on Thursday nights and he's always also going to buy beer to get ready for the weekend. It's a very highly contested hypothesis, by the way.